In this video, we look at a vertical free fall problem where somebody throws a rock straight up in the air with an initial speed of 12 meters per second, and the rock is released from a height of 1.8 meters above the ground. And in part A, we're computing the maximum height for the rock, and in part B, the flight time. So the key to looking at maximum height is that the y velocity must be 0 when the rock achieves its maximum height. This is because it's transitioning between a positive velocity and a negative velocity, so it must pass through 0 just for an instant. So that's our key physical point. Vy is going to be equal to 0. And then the quickest way to get to the actual maximum height is to use the kinematics equation. Vy squared is equal to v naught y squared plus 2 times the acceleration ay times y final minus y initial. And I plug in the fact that Vy is equal to 0 at the moment of interest. V naught y, the initial y velocity, is 12, and I need to square that. The acceleration is in the downward direction, so it gets a minus sign, and that has a magnitude of g, or 9.8 meters per second squared. So I have 2 times negative 9.8. And then my final y is what I'm interested in, and my initial y, that was 1.8. So to summarize the algebra from here, I square the 12, I subtract that over to the other side, and then I divide that by twice negative 9.8, and then finally I add 1.8 to it. And after I run all those numbers, I get a maximum height of 9.15 meters. In the next part, I'm asked for the time for the rock to hit the ground. And for this, I'm going to use our first kinematics equation. And what I plug in physically this time is that the final position should be 0 when the rock hits the ground. So I have 0 equals my initial height, that's 1.8, plus initial y velocity, that's 12, times t. And then I plug in that the acceleration is negative 9.8, and half of that is 4.9. So I have minus 4.9 t squared. This is a quadratic equation, and I need to use the quadratic formula to solve this thing, but I prefer to do that with a positive leading coefficient. So I'm going to move all the terms to the left-hand side. And I plug into the quadratic formula. And alternatively here, if you're allowed to use a quadratic formula solver in a computer algebra system or a calculator, that's fine too. And I get negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, which again is 9.8. Notice that that second part inside the square root has a double negative. So those terms are going to add to the 12 squared. Next, I simplify all the numbers inside the square root and take that square root, and I end up with 12 plus or minus 13.39, all divided by 9.8. Now, one of these times gives me a positive answer, and one gives me a negative answer. But this whole physical process started at t equals 0, so we can throw away the negative result, and I just keep the positive result, which results from adding 13.39 to the 12 in the numerator. And 12 plus 13.39 all divided by 9.8, that turns out to be 2.59 seconds. I'm just keeping 3 sig figs by default. And we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.